So we have, I think, 6 examples. I think we have 6 examples. So let's see. Is m squared a perfect square? Yes, m squared was made by taking m times m. Is 49 a perfect square? Yeah, what is the square root of 49? Yeah, the square root of 49 is 7. So we're going to put a +7 and a -7. And that's it. That's how you factor these. These are probably the easiest things to factor ever. The next one, the square root of 144 is what? Say it again. Is 12. Yeah. So what's it going to look like when I factor it, Austin?
P minus 12.
Perfect. P plus 12, P minus 12. Okay. Let's look at the next one. The square root of 25 is 5. Yes. What is the square root of 4t squared? Well, what number do you multiply together to get 4? 2. And what do you multiply together to get t squared? T. Yeah. So we're going to do 2t plus 5 times the quantity of 2t minus 5. What are your thoughts? Easy? Hard? I'll do one more. Which one do you want to do? First, second, or third on the bottom row? The second one, the middle one? Okay, let's do the middle one on the bottom row. So 64 is, like, what is the square root of 64? It equals 8. So I'm going to have 8 on the first parenthesis and 8 on the second one. What do I multiply together to get m to the 4th power? Think about your exponent rules. M times m gives me m squared. Good job. M squared times m squared. Okay. What do I multiply together to get 9? What's the square root of 9? 3. So I'm going to do plus 3. I'm going to do minus 3. And how did I make p to the power of 6? Yeah, p cubed times p cubed. So the cool thing about the variable terms is you just divide their exponent in half. When you're looking for the square root of a variable, you divide the exponent by 2. That's kind of the rule for that. You're going to divide the exponent by 2. So I'm going to freeze the screen, and I want you guys to do 9t squared plus 4 and 169r squared minus 256.
Wait, you said which one?
You're doing the 2 that we didn't do. The 2 that we didn't do. Something crazy is going on with my pen. It's like leaving these little streaks all over. I need to go get a new one. That's nice. So let's see. 9t squared plus 4 factors out to 3t plus 2, 3t minus 2. And 169r squared minus 256 factors out to 13r minus 16 times the quantity 13r plus 16. I'm gonna do a change up, see if we have any better luck. Okay. It says, oh, go ahead. I'm waiting.
The second one be a plus for the bottom one, considering the thing added in the first one.
Tell me exactly what you're talking about.
9 2 squared plus 4, wouldn't it be plus 2 on both sides?
So let's talk about that one. Good call on that. I wasn't even paying attention. Is this the difference of two squares? I don't have a working pen. Is 9t squared the difference of two squares? Does it say 9t squared minus 4 or does it say 9t squared plus 4? It says plus 4. Can we do that? Is that the difference of two squares? Is that a difference? It is not. I can't write. Dang it. It's not the difference. This is so crazy. This is not the difference of two squares. It's not joined by a minus. Good call on that, dude. This needs to be a minus, so this is not possible. Not possible. I'm writing with my finger today. That's going to be a nightmare. Okay, what about the sides? Go ahead. You can't do that because it's not joined by a minus. It has to be joined by a minus. You don't have an eraser? Here. I don't have a baby eraser either. So let's go down to factoring perfect squares. I'm going to go down to factoring perfect squares and talk about that. I'm changing out batteries and hoping that it works, but I don't know. Factoring perfect squares. So remember when we talked about a number, a binomial squared. So we talked about examples like x, this is not going to work, x plus 4, the quantity squared. And we said, well, that means x plus 4 times, I'm sorry, guys, it's going to leave those weird strings, times x plus 4. Okay. We talked about that. And we said, well, what do we do with that? And we just take that weird setup and we FOIL it, right? So we're going to FOIL that. So we know that x times x is x squared. I'm performing surgery on my pen, so I can't talk. X times x is x squared. 4x plus 4. No, I've got little styluses here. It's got to be this special Dell pen. It's really ridiculous. I think I've got it. Oh. Okay, cool. Maybe that'll work. Okay, so when we FOIL, we get x squared plus 4x. It's still even that weird string. Plus 4x plus 16. And we said there's a pattern to this. I don't know if you guys remember it, but we took the first term and we squared it. Then we did 2 times the first term times the second term, right? And then we added the last term, the square of the last term. That's the pattern. My pen is all broken. So anyway, we're going to just jump down to here. And I'm just going to tell you how to look at this. So you can factor this with a times plus chart if you want. You can do this just like we've been doing with a times plus chart. So what two numbers am I multiplying to? What am I looking for on the times side? What number am I looking for on the product? When I do times plus, what am I looking for? A times C is what? 9. And I'm looking for two numbers that multiply to 9 and add up to what? Add up to 6. So it's going to be 3 and a positive 3. So this is going to be x plus 3 times x plus 3. And because those are the same exact factors, we rewrite them as, Zach, put your phone away. I think you have that out. Yes? Yes? Okay. X plus 3, the quantity squared. Okay, we write it as x plus 3, the quantity squared. I'm going to go down to the one right below it.
I know what the next one is.
Okay, so
-5 times -5.
yeah, so let's fill out our times plus chart first. What two numbers are we multiplying to? A times C is 25, and they have to add up to -10. You guys have got to know how to do that. You've got to know how to piece that out. So we said that the two numbers are -5. So I have x minus 5 times x minus 5, which is the same thing as x minus 5, the quantity squared. Yeah. Okay, I'm going to do the last two on the right. I'm going to do the last two examples on the right, and then I'm going to come around and check homework, and then we'll post answers. Okay, let someone else try and think about it for a second. Okay, let someone else try and think about it. So, times plus chart. Let's fill out our times plus chart. What two numbers can I multiply together? What am I trying to find on the time side? 100. And what does it have to add to? 10. Okay. Sorry, 20. I know you said 20. So what are my two factors, Hayden? Yeah, positive 10 and positive 10. So x plus 10 times the quantity x plus 10, which is the same thing as, yeah, x plus 10, the quantity squared. Brian, you have the last one. So times plus, I'm looking for a positive 81, adds up to a -9. Let's see, let's think of factors of 81. How's that? Okay. Factors of 81, 1 and 81, 3 and 27. Let's see, it's not divisible by 4, it's not divisible by 6, it's not divisible by 5. The only other factor is 9 and 9, right? So is there any combination of these numbers? Is there any combination of these two factors, or these that is going to give me a sum of -9? No, so we just say that this is not factorable with integers. It is factorable. It's factorable with the quadratic formula, but we're not learning that. We're not learning that right now. So we just say it's not factorable with integers. This is not a special type of problem. Okay, so I'm going to go to the yesterday module and make sure that everyone, did you guys look in Canvas yesterday when you were in Miss Melby's room, Mrs. Melby's room upstairs? Yay. Okay.